now?
Yes, sir.
So last class we discussed about how authentication is done and how confidentiality is done, and I asked you to actually go ahead and do the okay. Let me add before going into this. Yeah. To do both authentication and confidentiality together. So that's quite important. So I would like to show you with a diagram. Let me write it. Okay, that's what means. So that you will understand it better. Okay, so now you are sending a packet from a mail from one system to another system, and then now you have a message. You have a ready message. Okay, so to provide authentication, what you are initially going to do, you are going to pass this message to a hash function, right? You are going to pass this message to a hash function. So once you pass this message to a hash function, what you will get? You will get a hash code of m. Let me write it as h of m. Okay, you have h of m. Now for this h of m, I will add the actual message. Is that clear, students? Now this h of m and actual message. So how do you go ahead with this now? Or forget about this. I will just remove this. Okay. Now tell me, for providing authentication, like what you will be doing with this h of m. Generally, what you do?
Encrypt that hash code with the sender's private key.
Okay, so let me encrypt it. Encrypt this with key sender private. Clear? Now, so if you send this, authentication and integrity is proved. Now you have to prove the confidentiality also. So this is what I have here is basically this is digital signature. Okay, write it here, digital signature. Okay, so now what is the next step? For this, you are supposed to add what? Can anyone tell me?
The message.
Okay, after adding the message, what you are going to do?
Encrypt using sessions key.
Okay, so what I will do here, I am adding the message. Okay, so I will pass this. Okay, let me pass it to a encryption function. So okay, since I have less space, what I will do is I will this also I will remove, students, to avoid confusion. Okay, see, you have a message, you fed it, you actually given that message to a hash function, you got the hash code, and that hash code was encrypted with the session sender's private key, and for that you are adding a message, and this whole thing,
Sir, message is added for integrity, no sir?
what?
Message is added for integrity, right? Not confidentiality.
Yeah, I agree, but see, message you have to send. No, message is your actual message, what you want to send, the data. Okay, you gave that data to your hash function, you got the hash code of that message, that is h of m, and then that h of m, the hash code, you are encrypting using the sender's private key, so that to confirm the authentication. Okay, now with this is what this is actually, let me write it here. Yeah, this is your digital signature. Okay, this is your digital signature. For the digital signature, you are adding the message as it is. What you said is right, because when you send this to the other end, what happens, message will be there, and the hash code of that message will be generated by the receiver, and that hash code with this hash code, because receiver can decrypt it using the sender's private key, public key. So that hash code and this newly generated hash code will be compared, and if they are same, integrity is proved. Okay, authentication also proved with the help of digital signature. Now these two, this digital signature and message, I have to encrypt it using what key, students?
Session key.
Yes, using session key, ESE. Okay, so now again, so you cannot send the session key as it is, right?
Sir,
Yeah.
should we also send the hash function? We don't know which hash function to use it in M, no, sir.
No, that will be initially discussed when you see, when you have a initial communication, initial TCP connection. In that TCP connection, you will have a connection establishment phase, right? That time you will actually discuss. Your systems will do that. Okay, which hash function you are using. You need not send what hash function you are using.
Yes, sir.
Now you have the digital signature plus message encrypted using the session key, but you cannot send the, when you send it to the receiver, receiver doesn't have the session key, so you have to encrypt the session key. You have to encrypt the session key with what?
Public key of receiver.
Yes, so let me write it. I am encrypting the session key, that is key S E is encrypted is encrypted using, just add encryption, using public key of receiver. So it is KR plus. Okay, so this is session key encrypted using the public key of receiver, and then you have hash code, that is H of M, encrypted using sender's private key plus message encrypted all together with just a second. Encrypted using key session. Is it clear, students? Initially you have a message, you are giving that message to hash function, you will generate the hash code of that message. I will call it as H of M, and that H of M will be encrypted, that hash code will be encrypted using the sender's private key. You call that as digital signature. You are appending message to the digital signature, and hold to all together you are encrypting using a session key. If you do this, the receiver has to decrypt this whole thing using the same session key, but you cannot send the session key as it is. You have to encrypt the session key also. With what you are encrypting the session key, so that only receiver can decrypt it. If you encrypt the session key using the receiver's public key, the other key pair, that is receiver's private key, only has to be used to decrypt it. So session keys are encrypted using the sender's public key, and it is appended with the whole thing, whatever you have encrypted using the session key. So this will be sent to the receiver. So this is what I will call it as sender. Okay, So in the receiver side, basically what happens? So initially what happens in the receiver side? So receiver will receive what? Receiver will receive this one as it is. So it is key session. So that will be decrypted with what, students? Key session key will session will be decrypted with receiver's private key, and this whole thing h of m plus message will be decrypted using this session key. Okay, then what happens? You have h of m plus m alone. Is that clear? Now from this, what you got? You have proved confidentiality here. You have proved confidentiality. Now you have h of m and m. So you are giving this h of m to a hash function. You will generate one more h of m. Okay. So authentication is proved with the help of digital signatures. Okay. So this h of m and this newly generated h of m will be compared, and for integrity is also proved. So students, when you write the diagram, if you get a question like represent this whole thing, confidentiality and authentication together provided by PGP, you have to clearly mention, or you have to clearly write the diagram. Each and every step you have to write, which is not written here. Is that clear? But I have clearly shown you the diagram of authentication and confidentiality. You have to combine it all together. Is it clear, students? Shall I erase this and go to the next slide? You have any questions in this? Hello? Am I audible?
Yes, sir.
Questions, sir.
Okay, sir. Okay. If there are no questions, you please tell me. Okay. So that's about confidentiality and that authentication. That is quite important, students. That's why I was stressing more on that. Okay. So see the separate diagrams for authentication, and this is for confidentiality. Okay, you have to combine those, and I have a diagram in the textbook also, which I will add to this slide. Okay. So the next thing is compression. We will move on to the message processing functions. Okay, so we are not going in depth towards how this protocol will compress the zip will compress the mail, but you should know what protocols we are using. That is good enough. And when you are going to do the compression, that is one more important thing. By default, PGP compresses a message after signing, but before encryption. Please keep this in mind, students. Only after signing, that means only after digital signature, it encrypts the mail. Is that clear? It encrypts the message, but before encrypting. Is that clear, students? So keep this in mind. So let us see why signature is generated before compression. Can anyone tell me what might be the reason? Why signature is done before compression? Okay.
Sir, there can be some loss, like lossless compression and lossy compressions are there, no, sir. So by generating a signature after compression, it would not be accurate. So we are not getting the actual uh, data signature. So
Yeah,
before compression only
you
we have.
are almost right. Okay, so just take this point, student. To facilitate the storage of only the plain text version plus signature, this is the point I am giving you is the reason for doing compression before doing compression before after signing. Okay, or you can take a note like this. Signature is generated before compression because signature is generated before compression because signature is generated before compression because first point, it facilitate the storage of only the plain text version plus signature for later verification. That means you have digital signature that you have generated. So how signature is generated, I have already told you, plus message. Okay, these two will be compressed. Okay, these two will be compressed. Only after compression you will actually encrypt it. Is that clear? So compression signature is generated before compression because it facilitates the storage of only the plain text version plus signature for later verification. Second point, it facilitates successful recompression. See, what is recompression? See, PGP compression algorithm is not deterministic. Okay, various implementations of the algorithm achieve different trade-offs in running speed and compression rate. Is that clear? So thus recompression for the verification is bound to fail if the signature was generated from the compressed message. Is that clear, students? If you generate a signature after compression, the verification may fail because in the other end verification may change when you again generate when you try to get the hash code of it. So basically what you have to know here is compression is done after signing and before encryption. Is it clear, students, about the compression? So yeah, here it is there. Because the compression algorithm is non-deterministic, various implementations of the algorithm achieve different trade-offs in running speed versus compression ratio, and as a result produce the different compression forms. So in that case it is quite difficult to verify. And the next thing is yeah, which signature compression algorithm you are using? The PGP is using. PGP uses zip compression algorithm. Is that clear? And we are not going to see how exactly zip works. So that's not in your syllabus. We just have to know what algorithm is used, why compression is done, and why at what time it is done. That is more important for us. Okay. So the next thing is after compression, it is compatibility. So which software is used or which technique is used for conversion of email into a proper compatible format? We'll see that when using PGP, we'll have binary data to send, so encrypted messages. However, email will designed only for text. Hence, PGP must encode raw binary data into printable ASCII characters, because whatever you type here has to be converted into binary, and once it reaches the destination, that again also has to be converted into the proper ASCII characters. Is that clear? So for that there are many encoding techniques, students. So Unicode is there, Radix 64, few more are there. So here PGP uses Radix 64. Okay, so why Radix 64? What is the way in Radix 64 encoding happens? There are a couple of problems. We will solve that in the next class. Is it clear, students? Am I clear to you?
Yes, sir.
Okay. Okay, I think we'll stop for the day. You have a class at 9:30. So next class we will discuss about what is Radix 64 conversion, how the conversion is done. If I give you a simple text, how conversion will happen, and then we will see why do we require segmentation and reassembly. After that, we will go to the key rings and session keys. Okay. So we'll stop here today. You can leave, students.
Thank you, sir.
Okay.